Good afternoon everyone, my name is Bunyunjan with manual number 178950. Today I'm going to make a summary on what I've learned from the YouTube video that is about the electrical and electronic measurement. And under this topic, what we are going to learn is we have to learn about the error analysis, we have to learn about the PMMC, MI dynamometers, induction type instruments, and the third one is the bridges and potentiometer. Fourth one is measurement of voltages, current, power, energy, and also the power factor. And the next one is a digital voltmeter and multimeter. And the following one is a phase. We have to learn about the phase, how to measure the phase, the time, the frequency by observing on the oscilloscope. And then is a Q meter and also the potentiometric recorders, and finally is a instrument transformer. So before we learn about all this, we have to know, firstly we have to know about what is actually the measurement, what measurement is. So measurement basically will mention about the unit, and actually unit is very important when we doing some calculations. When we make some measurements, unit is very important. For example, if we measure about the length, without the unit, we can say the length is 10. But what is a 10 actually referring for? So that's why unit is important, because without the unit, we can say that the 10 maybe is a 10 meter, 10 centimeter, 10 kilometer, or so on and so forth. So every numbers must be followed by the unit. After we have understand about what is the measurement is, we look at the first topic today, that is about the error analysis. So first of all, what is error? Error is actually the difference between the measure value and the true value. So if by calculation method, that is with equations, error is equals to measure value minus by the true value. So the definitions of error is the deviations of measure quantity from the actual or true value is known as an error. So error can be positive and also negative, and it depends on the measure value and the true value. If for positive error is the measure value will be greater than the true value. If for negative error, the measure value will be less than the true value. So secondly, we look at the correction factor. What is a correction factor? Correction factor is the opposite of the error, which is the negative of error. So in definitions, the correction factor is a value which we have to add or subtract from the measure value in order to get the true value or the actual value. So if let's say the error what we obtained the error just now is in positive error, and then the correction factor will be negative. If the error we obtain is a negative error, then the correction factor will be the positive value. So under the errors topic, we can actually divide it into two types, which is the static error and also the dynamic error. For the static error, is independent of the time, and then for the dynamic error is dependent of the time. So it's actually opposite to each other. And finally, the topics that we will learn today is the relative static error. What is a relative static error means? Relative static error is actually used to determine the quality of the instruments. It's actually very important, because when we want to use the instrument, then because let's say there's two instruments used to measure the readings, but then with the different scale, which one will be more reliable? Then we will look at this relative static error. If the relative static error is lower, that means the device that we use is more reliable. And then in the equations, the relative static error is equals to error divided by the true value. And then in percentage means is equals to the measure value divided by subtract minus by the true value, and then divided by true value multiplied by 100. So that's all from me. Thank you.